Hi friends, welcome to LTechpedia. Now we will see GATE 2016 question paper for electrical and the concept of electrical circuits. Now we will see the problems. The first problem is RA and RB are input resistance of the circuit as shown in below. Circuit extend infinitely in the direction shown. Which one of the following statement is true? That is, they were required, which is the correct equation for the extended resistor network. So here RA and RB, so that is equivalent value. So RA RB from this equation, so we calculate the multiplication of ladder equation as resistor connected in series 2 ohm in parallel 1 ohm. So it is simplified as, so 1 ohm resistor with RA. So RB is the equation of the simple changes in a RB. The extra 1 ohm resistor is connected behind the 2 ohm resistor here, so that's why it will be parallel to RA value. So others are same, so here consider others are same, so it will be parallel with 1 ohm into RA. So actually in general in parallel network we will write as 1 into RA divided by 1 plus RA, R1 into R2 divided by R1 plus R2. This is formula. So here consider 1 into RA into 1 plus RA. So final equation for the RB. So this is the statement RA divided by 1 plus RA. So for the expanded network of RB shown as RA divided by 1 plus RA value. Then move to next. In the portion of a circuit shown in figure, if the heat generated in 5 ohm resistor is 10 calories per second, then heat generated by 4 ohm resistor in calories per second. So they were provide the value of heat dissipation in 5 ohm resistor is 10, but they required heat dissipation in 4 ohm resistor. Actually 4 ohm resistor is connected in parallel of 5 ohm resistor, but in series with the 6 ohm resistor. So first we calculate 1 calorie per second. So we know about the 1 calorie per second is 4.184 watt. So heat dissipated in 5 ohm resistor is 10 calorie per second. So we want to watt calculation, so 10 into 4.81 into 4, so overall function is 41.84 watt. Then heat dissipated, it is nothing but I square R. So I square into R, we know the value R value, then I square value, so I square value we don't know, so we want to calculate. So x is equal to 41.84 divided by 5, the whole term will be squared, then we get the function 2.89 amps. So this is current value. Then voltage across 5 ohm resistor and 4 plus 6 ohm resistor, series connection of 4 plus 6 ohm resistor we want to calculate. Both are parallel connection, so voltages are equal. So in this case we want to calculate the transfer function, that is branch current, transfer currents. So we want to calculate the branch current Ix and Iy. So we know Ix value 2.89, so we want to calculate Iy value. So both are parallel, means both the voltages are equal. So Ix into 5, Iy into 4 plus 6, both are series, that's why we were cascading. So Iy is equal to 2.89 into 5 divided by 10, so Iy is equal to 1.44 amps. So this is secondary current, so second branch current flowing in a 4 ohm resistor is 1.44 amps, but we want the function heat generated by 4 ohm resistor. So I square into R, I square is 1.44 into R value is 8.368 watt. But in a question they were asked in calorie per second. So already we know 1 calorie per second is 4.81 184 watt. So we want calorie per second, mean denominator, divide those things, so we get 2 calorie per second. This is the final answer for given problem. Then move to the next. In the given circuit, the current supplied by battery in amps, they were provide one circuit. In the circuit, how much current they provide the battery, we want to the calculation. So we consider super mesh. So here consider super mesh current I2 in current source at a bounded of 2. So here consider this super mesh. So in this super mesh calculation we consider two current. So I1 and I2 are in consider with I2 super mesh current. So move to this one, we will calculate the value of node current I. So here go to the nodal analysis. So at the function of n, I1 is incoming, both I2s are outgoing. So that's why I1 is equal to I2 plus I2, this I2 and then another one is this. So I2 plus I2. So I2 value is 1 divided by 2 because this is 2I, 2 will be denominator. So I2 is equal to 1 divided by 2. Then applying KVL to the super mesh. So from this equation, so we want to frame this one. So minus 1 into V. So this is minus 1 into V plus I1 plus I1 divided by 2. We know this I2 value plus I1 divided by 2 equal to 0. Then we want the function I1 equal to this 2. The value is 2, I1 is equal to 1, I1 is equal to 1 divided by 2. So final answer is 0.5 amps. So this is the current supplied by the voltage. So this is the first current. So I1, so current supplied by the voltage is 0.5 amps. Then move to the next. In the circuit shown in figure, switch S2 has been closed for a long time. S2 always closed for long time. At time t is equal to 0, switch S1 is closed. At t is equal to 0 plus instantaneous, the rate of change of current through the inductor, what is the value of inductor current in amps per second. Here second switch is always connect, where S1 is connected at t is equal to 0. But what is the value of instantaneous? Same, instantaneous is 0. So what is the value of instantaneous current in a inductor? We want to calculate those things. So move to this. At the time t is equal to 0, network in a steady state with the switch S1 is worked and S2 is closed. So this case we calculated an inductor current. So here inductor current is flowing here, so it is open, here no possibility of current. So here possibility of current is there. So we want to calculate IL of 0 is equal to volt per resistance, so 3 by 2, that is 1.5 amps. Then at the time of instantaneous t is equal to 0 plus, apply the KCL at the node of A. So here VA, so consider this is VA value, then VA so this point is nodal point, so consider VA minus 3, so applied voltage is 3, VA minus 3 divided by resistor 1. So first function, another one is V3 divided by 2. So this second consideration, 3 divided by 2. Then another one is VA minus 3 divided by 2. So this is final one. So consider here, already we calculated this value, that is 1.5. so here considers 3 by 5. So here written as 3 by 5, that is 1.5 value. So why here write as 3 by 2? We want to take an EC LCM, that's why. So multiplied and taken LCM 2 and cross multiplied to 2 as 0, and 2 into VA minus 3 plus 3 plus VA minus 3 equal to 0. From this equation 3 VA is equal to 6, so x divided by 3 equal to 2. So VA is equal to 2. So we want the function current flowing through the inductor in amps per second. So in this case VA is equal to L di by dt. So di by dt, rate of change of current, di by dt, that is VA is equal to 2. So di by dt, VA is equal to 2 by 1. So inductor value is 1, 2 by 1. So total current is 2 amps per second. So this is the final answer. Here L value is 1. Then move to next. In the circuit shown in below, the supply voltage is 10 sin 1000 t volt. Then the peak of the steady state current through 1 ohm resistor in amps. So here only 1 ohm resistor connected in between the many different circuit. So we want to simplify this one, and finally we calculate those things. Here sine omega t is equal to sine 1000 t, that is omega is equal to 1000 omega per 1000 radian per second. Then parallel LC circuit will offer infinite resistor, that is open circuit. So this this LC circuit offers the infinite resistor, so it will be open. Similarly here LC circuit is there, so here also open both. So we have only the network, so we want to modify the whole things. So here whole things means they were provided C, so it will be rewritten as j omega jc. That's why here the calculators 2 pi into f, that is 2 pi fc, then 1 divided by 2 pi fl. So they were provided this formula 1 divided by 2 pi fc and 2 pi fl. So then calculated, both are infinite provided, so both are opened. So we have only circuit in a 4 ohm, 1 ohm, 5 ohm resistor. Now both are open mean all are having in a same format, so seriously connected. So seriously connected means the voltage and current through the 4 ohm, 1 ohm, 5 ohm and connected with, so it will be going like this. So in a both are in a series. So series means 4 plus 1 plus 5, we want a current I is equal to V divided by R. V is equal to 10 sin omega t sin 1000 t divided by 4 plus 1 plus 5. So final answer I is equal to 1 sin omega t. So maximum current is 1 amps. So this is the final answer for given problem. So next to move to the another problem. The circuit below is excited by the sinusoidal source Vs. The voltage, the value of resistor in ohm, so they were not provided resistor ohm, for which of the admittance of the circuit become a pure conductive at all frequency. So here resistor value is ohm. So what is the condition for pure conductance of the network circuit? So here taking identical time constant, so first one is tau L, second one is tau C. So both the conductances purely means tau L is equal to tau C. So time response tau L is L by R for case 1, then second case RC. So first case L divided by R, second case R into C. So cross multiply both, R square is equal to L by C. We want the function R only, so R is equal to root of LC. So we know the function root L and C, they were provided. L is 0.02, C is 100 into microfarad 10 power minus 3. So simplified those things, we get the function R is equal to 200, that is root 200 is equal to 14.14 ohm. So this is the value for R value. Next problem. In the circuit shown below, the node voltage VA is, so they were want voltage VA. For this case we want to calculate one by one. So first we want I1 current. So I1 current will be calculated for the branch of this. So for this case VA minus 100, VA minus 10, so this branch will be connected with this. So VA minus 10 divided by 5 plus 5. So this term 5 plus 5 10. So VA minus 10 divided by 5 plus 5 10. Overall function is VA minus 10 divided by 10. So this is considered as equation 1. Then go to the KVL at A function. So same here going means those who are considered 5 minus, okay, VA divided by 5 plus 5, then VA minus 10 I1 divided by 5, then VA minus 10 divided by 10. So this is the overall function here rewritten as, so VA by 5 plus VA value minus 10 I1 divided by 5 minus 5 plus VA minus, that is first term is VA divided by 5, second is VA minus 10 I1 divided by 5, third is minus 5, fourth one is VA minus 10 plus 5 into 5 10. So we write as 10. So these are the KVL equation. From the equation 1, so we know the function from equation 1, I1 is equal to VA minus 10 divided by 10. So substitute the IA1 value here. So I1 value substituted means we got VA divided by 5, VA by 5, so this 5 is common, VA by 5 plus 2 into VA minus 10 divided by 10 plus VA minus 10 divided by 10 minus 50, that is taken as common LCM. 50 is equal to 0. So here first we take common LCM, then move to the 1 by 1, and finally we write it as similarly. So whole term is considered and taken as 0. 2 VA, so here 10 is maximum, so 2 VA in plus 2 VA plus 2 into, here 10 is common, so 2 VA minus 10 plus VA minus 10 minus 50 is equal to 0. Then finally we calculated 7 VA equal to 30 plus 50. So the constant as 2, 2 plus 2, 4, 4 plus 2, 6, here 1, 7 VA, then here 10, then another 10, then finally we calculated here the 50. So overall function is 30 plus 15. So here VA is equal to 11.42 volt. So this is final answer. Here 2 into 10, 20, here 1 is 10, 30, totally 30, minus of minus that side going, so after equation it will be considered as plus, so 18. So VA is equal to 11.42 volt. So this is the final answer for given problem. So for this problem we want the nodal function voltage VA is equal to 11.42. Thank you. Thank you for watching. If you like this, means share and subscribe. Thank you.